are working with R squared today. And this does... Question 3, this one is not optional. Make sure you have done this question. Suppose that you collect the following data for 5 random students in your class. What is the correlation coefficient R? Why is the data unusual? In the context of this problem, what does the correlation coefficient tell you about the association between height and shoe size for these unusual students? So, let's do it. You guys have your calculators. Put this down a little bit. Okay, so first thing you got to do is step 1. So second plus 712, and your calculator is cleared. Step number 2 says hit mode, up 3 times, then go over to stat diagnostics, press enter to turn that on. Step 3, you're going to enter the data, so stat enter. Go ahead and enter the shoe size for your L1 for your X. 6, 7.5, 8, 8.5, and 10. And go ahead and press right so you can go over and enter your height. All right, now that we have those 5 shoe sizes and 5 height entered, we can go to step 5, which is finding that regression. Notice we can skip step 4 because we're not drawing a scatter plot. Step 4 only lets us visually see the scatter plot. We don't need to see the scatter plot for this one, so we can skip it. But if you do step 4, there's nothing wrong with that. Step 5 says stat right 4. Press enter a bunch of times, and then finally you get done to calculate. Press enter one more time, and we get our values there. So let me move this back up. So what is the correlation coefficient R? Well, I can see right on the calculator, R equals 1. So the next question says, why is this data unusual? And in the context of this problem, what does the correlation coefficient tell you about the association between height and shoe size for these unusual students? Okay, if you get an R value of 1, that means that is a perfect positive correlation. So the reason this is unusual is because usually nothing's going to be perfect. So that's what's unusual about it. It's a perfect positive correlation. All right, question B, what is R squared? What can you say about the variability in height of these unusual students in your class? If we look at the calculator, R squared equals 1. And then we want to turn that into a percentage, so I move the decimal over 2 spots, and I get 100%. So what can you say about the variability in height for these unusual students in your class? Once again, I'm going to use that sentence on the front page, so if you need to flip over your sheet, go ahead and flip it over. Otherwise you can just write it from memory. So 100% of variability of height can be explained by a linear relationship with shoe size. Once again, why is this unusual? Well, this means that the only factor of height is your shoe size. And as you know, there's a whole lot more that goes into height other than just what their shoe size is. But question C, based on your results for R and R squared, what can you say about predicting height for a student in the class? And our answer to that is we can predict it with 100% accuracy. We know exactly what it will be, which is really cool. And obviously, as you guys can imagine, highly unlikely.